back. Limit x approaching pi over 2 from the left of secant x. It's similar to the problem we just did. Secant x. What is secant x? Secant x is 1 over cosine x. So let's first figure out how cosine looks like, right? So cosine looks like, right? At 0 it is 1 and then it goes down and then it climbs up and then it goes down and so on. Likewise, same thing here. Okay, so where is it that it's hitting x-axis? So this is pi over 2. All right, so this is cosine x. All right, so what about secant x? Secant x is reciprocal of cosine. So wherever it hits 0, it will go to infinity. One of the infinities, positive or negative. So when you are above, it will go above. All right. And when you are below, cosine is below, secant will be below. All right. So my drawing is not very clean, but I hope you understand why the picture looks the way it does. Okay. So let's try and get a good diagram here. First, let's draw cosine of x. Aha, that looks good. And now let's add secant of x. You see, secant of x is in green, right? And cosine of x is in blue. All right, so let's zoom in. Okay, this. You see? So what's going on? So that is pi over 2. So I am interested in secant pi over 2 to the left. So somewhere there is pi over 2. To the left, that is, that curve is secant. It goes to positive infinity. All right, next one. Okay, now this again using pre-calculus you can you need to factor the denominator and worry about limits, etc. Or you could simply draw the picture and figure out how this looks like. All right, so let's draw the picture. X over x to the power 2 minus x minus 12. Okay, so you have vertical asymptotes over here and over here. Question is, what are their values over here and over here? So their values will be when x squared minus x minus 12 is 0, when the denominator is 0. So x squared minus x minus 12, if you factor it, it is x minus 4, x plus 3. So that gives me a negative 3 and positive 4. So negative 3 and positive 4. I hope it's clear. If I set it equals 0, I get x equals 4 and negative 3. So we write the smaller number first. All right, numbers with commas. All right, and the last one, you want to find equation of the first vertical asymptote to the right of the y-axis. So when is tan equals 0? So vertical asymptote, when does tan go to infinity. Tan goes to infinity at pi over 2. So 10 pi over 10. So let's write this down. First, let's draw the graph of tan, so you have a feeling for how it looks like. Tan of x. So tan of x keeps going to infinity. You see, it's a repeated picture. It has period of pi. So from negative pi to pi. Then, negative pi over 2 to pi over 2. Then pi over 2 to 3 pi over 2, and so on. So the first vertical asymptote for tan on the right is when x is pi over 2. Okay, so the first vertical asymptote for y equals tan x is when first vertical asymptote to the right of 0. Okay, that's important. We are looking at the right hand side. Is when x equals pi over 2. Now, we don't have simply tan function. We have tan of 10 sine x. In other words, you want 10 sine x to be equal to pi over 2. So sine x equals, divide both sides by 10, right? So pi over 20, because dividing by 10 multiplies to this 2. In other words, what is x? It is sine inverse, right, of x. Sine inverse of pi over 20. That's what you want. So let's try. Arc sine of pi over 20. I hope WebWork recognized arc sine. Yeah, it did. All right, so that's sine inverse. So this completes section 1.5. Next videos will cover section 1.6, very important section. Okay, until then, bye.